Good morning, students. Now we are going to discuss about the iterator pattern. And iterator pattern is an object behavioral pattern. So next we are going to the intent. So what is the intent of iterator pattern? Defines the short answer or the meaning of the pattern. It provides a way to access the elements of an aggregate object sequentially without exposing its underlying representation. Before this, the one word you have to remember is nothing but what is meant by aggregate objects. So aggregate objects is nothing but not exposing internal structure. It exposes only the external structure. Those context of an object we can define as an aggregate object. So you all know that this iterator pattern is solves the design problem as spell checking. Spell checking is a design problem, which is used to check the misspelled words when the framework is going on. This iterator pattern is mostly used to solve such type of design problem as spell checking. So it is also known as cursor, and before that, intent means provides a way to access the elements of an object sequentially. So for example, if you take any misspelled words like let us take the example as computer as a word. If the computer, when we are going to performing a document, in that the computer word is typing, if there is any mistake or misspelled word defined as a computer, then this iterator pattern applies in such situations to check whether that word is misspelled or not. So this is the best pattern used to solve the such design problem as a spell checking problem, and it is also known as cursor. Why? Because the cursor was named. It is the well-known names for the iterator pattern is nothing but there is main three operation performs in the iterator class, which is nothing but current item, next item, is done item. So current item means the cursor defines the current item. Next item means the cursor will move to the next item. Done item means is done item operation means the cursor performs the completion of the object checking or element checking. So that's why it is also known as cursor. And next template is motivation. Motivation defines the design problem and also finding the solution to that problem. The main key idea in this pattern is to take the responsibility for access and traversal out of the list object and put it into an iterator object. So the main key idea of this pattern is nothing but performing the traversals. So you all know the traversals like pre-order traversal and post-order traversal. If we take the computer as a word, if it perform the current element, from that element, all the elements before that current item is nothing but pre-order traversal, performing the pre-order traversal. If the word defines the current item as performs the next elements is nothing but a post-order traversal. So here the traversal point or traversal technique will be performed in the iterator pattern. So for example, here we are taking the two ways. One is list class. What are all the object elements can be needed to check as a misspelled words, and list iterator class means repetition. Whatever the object elements is need to be going to check is comes under the list iterator. Here we define the abstract list class that provides a common interface for manipulating list. Manipulating means if there is any appending, nothing but adding or removing or some whatever the modification should be done in the list. That's why there is need to create the abstract list class. So this is the main key idea of this pattern, and it is a motivation diagram. So I am telling here we are taking the one iterator class, abstract list class, and skip list. Here we are using skip list is a data structure which performs all the object elements which is need to be accessed from the abstract class and from the iterator class. So here we are performing the list as all the list of object elements. List iterator class means whatever the first item is performed, next item is performed, done item is performed, or whatever the current item is performed. So here see this abstract list. So this is the main abstract list class which defines the create iterator, count, append, remove. Create iterator means iterator class will be created, whatever the object need to be checked, and count, whatever the object elements need to be count, which iterator item object can be append adding, or which is need to be removed, all can be defined in the abstract list. And iterator class defines the first item, next item, is done item, current item. So this defines the list class. Abstract list defines the list class and skip list class. Same abstract list which defines as iterator class, list as list iterator, skip list as skip list iterator. So this is the motivation diagram. Next, coming to the applicability, where the pattern is applied, in what situations the pattern is applied. So use the iterator pattern. Use the iterator pattern when to access and aggregate objects contents without exposing its internal representation. So I already told you aggregate objects means, so this is aggregate objects without exposing its internal representation, where the internal we no need, there is unnecessary of object internal structure. Just this object internal structure can be restored. In that case only we'll go for this as an aggregate objects, and this pattern is applied. So this is without exposing its internal structure, only the aggregate objects can be accessed. So there the situation will apply the iterator pattern. And when to support multiple traversals of aggregate objects. So by taking those aggregate objects, we support the multiple traversals like pre-order traversal and post-order traversal. So here I am telling the example of two traversals. One is pre-order and post-order. So if the object elements need to be checked before the current item is a pre-order traversal, and after the current item is a post-order traversal. In this traversal algorithms will go for this pattern, and this pattern is applied in such way. So the next applicability is when to provide a uniform interface. So whenever the interface defines the uniform accessing of an object, uniform means one after another. After completion of one object element, the another object element is need to be checked. That is the uniform way which performs the uniform interface which is need to be provided. In that case, in that situation also, this pattern is applied. So next one, template structure. So structure of iterator pattern. This is the iterator pattern. Here we are taking the aggregate objects. So this is the aggregate objects, and here we are taking the main class as an aggregate class. So this is aggregate class, and here performs the operation as create iterator, and iterator class will be created. So same operations, first to next is done current item. Aggregate extends based on the subclasses like concrete aggregate. Here also concrete iterator will be created based on the concrete aggregate operation. So this is the structure: aggregate, concrete aggregate, iterator, concrete iterator in the client as usual. So this is the structure of iterator pattern. Next, coming to the participants template. So here from the structure we define the participant: iterator, concrete iterator, aggregate, concrete aggregate. So iterator defines the sequential access. Concrete iterator defines whatever the iterator classes created from the iterators like list iterator, skip list iterator, and aggregate is nothing but abstract list. Concrete aggregate is nothing but list, skip list. So this is nothing but participants who are participated, nothing but what are the classes and objects are participated in the structure. Next, coming to the next template, collaborations. So concrete iterator keeps track of the current object in the aggregate and can compute the succeeding object in the traversal. So exactly here, see here this collaboration, succeeding and preceding. So I told you that pre-order traversal and post-order traversal. Pre-order traversal and post-order traversal based on the current item. Before current item it is a pre-order traversal, and after current item it is a post-order traversal. Here preceding and succeeding means before current item it is a preceding objects, After current item means it is a succeeding object. Whatever the succeeding objects can be defined based on that can be defined as a collaborations as abstract list and concrete aggregate, like aggregate and concrete aggregate, abstract list and skip list or skip list. So this is the collaborations or the responsibilities that carried out by the participants. So this is a collaboration template. Next one is consequences, results. In what way this pattern is applied? That is the first result is nothing but it supports variations in the traversal of an aggregate. So whenever this iterator pattern applies, we can face number of variations based on the traversals. Either it is a pre-order or post-order or succeeding or preceding objects. All objects or traversal algorithms can make a number of variations to the clients. Why? Because so every word to word checking is need to be defined as an aggregate objects without exposing its internal structure. So it supports number of variations in the traversal of an aggregate object. So that is one of the main consequence. For example, if you take the code generation and semantic checking involve traversing parse trees. So code generation and semantic checking mainly it involves the traversing and parsing trees. So code generation may traverse the parse tree in order or pre-order traversal. There is a in order traversals and also pre-order traversals based on the code generation way. Iterator make it is easy to change the traversal algorithms. So that is the main result which we are facing when this pattern is applied. The first one. Second one, iterator simplifies the aggregate interface. Whenever we take the iterator traversal interface, the need for a similar interface in aggregate, thereby simplifying the aggregate's interface. There is mainly need of the aggregate interface. There we need to simplify the aggregate interface for better results. So this is the one of the consequence. The next one is more than one traversal can be pending on an aggregate. So here this defines an iterator keep track of its own traversal state. I already told you that iterator every state can be stored. It doesn't expose the internal state. It stores the restores the internal state wherever we need. So this is the main advantage of iterator pattern. So it owns traversal state. Therefore, you can have more than one traversal in progress at once. So if there is any need of restoring the object internal state, need of restoring, so in such cases this pattern is totally useless and it gives the better results when this pattern is applied for spell checking design problem. So this is the consequences. Next, coming to the implementation. So here some of the questions may arise in the implementation technique. Who controls the iteration? Who defines the traversal algorithm? How robust is the iterators? So these are some of the questions rises when the implementation technique defines as iterator pattern. So other implementation techniques as it has iterators may have privileged access. Iterators per composites. The first one is who controls the iteration. So this defines controlling of the iteration defines mainly 2 points. Who controls the iteration? Who performs the access object access elements sequentially. So all can be defined with the who controls the iteration. Mainly two iterations is there, external iterator and internal iterator. So external iterator. So here there is two ways performs. So if the client controls the iteration, it is known as external iteration. If the client controls the iteration, it is known as external iteration. If the client itself controls if the iterator class itself controls, then it is known as the internal iteration. So remember these two main points, external iteration and internal iteration. External iteration means client controls the iteration, it is known as external. Iterator class itself controls the iteration, it is known as internal iteration. So this is by using these two iteration classes, one is external and another one is internal, this pattern is implemented. So next one, who defines the traversal algorithm? So this is another implementation techniques. defines the traversal implementation is nothing but, so the before this I told you that there is need to define, need to expose, need not to exposing the internal structure. Only the internal structure information or keeping track of all the information can be stored, as in one of the way the state will be stored, and this total this state or this idea of key idea of this pattern defines is known as a cursor. So this is under who defines the traversal algorithms means the cursor defines the traversal algorithm based on the iterator class, based on the abstract list, based on the concrete aggregate objects, and the aggregate objects all can be defined in the who defines the traversal algorithm. And next implementation technique is how robust is the iterator. A robust iterator ensures that insertions and removals won't interfere with the traversal, and it doesn't copying the aggregate object. How robust is the iterator? Mainly robust means strong. This is the word. This is the meaning of the word. Robust means generally strong. So how strong the iterator class will be? Why? When it will be means when the removals, when the insertions and removals can be performed. That type of iterator class defines the strong class. Nothing but a how robust it was performed. How robust it is when the insertion and removals done correctly. When the copying of aggregate objects done correctly, then it is a robust class, the iterator class. So here the next one is nothing but iterators may have privileged access. So privileged access, although privileged access means if there is any accessing of list class from the abstract list to the skip list, list to the skip list, abstract list to the iterator, or aggregate objects to the iterator, or concrete aggregate objects to the concrete iterator. Wherever the iterator classes can be defined, or how defining as a robust or defining as a accessing of those objects sequentially, there need to be privileged access rights for every iterator class. So this is also main implementation technique. So next one, iterators for composites defines the tree structure, whether the first object is need to be start as a root, the next object is need to be starts as the intermediate node, and the next object is need to be start as a child node. All these iterator classes are also represented as a composite classes which need to be implemented in this way. So there is another point, null iterators. So null iterators also degenerate iterator that is helpful for handling boundary conditions. If there is any limited conditions, or if there is any boundary conditions, if you have to define the 8 character word, then we have to define only 8 character word, not 9 character or 10 character. So if the 8 character, if the limit is crossed to the 9th character, then it is a null iterator. So that a null iterator is nothing but a degenerate iterator that is helpful for handling boundary conditions. So this is also main implementation where the null iterators. So this is the implementation technique. Next, coming sample code. So this is the sample code. Main abstract class is the aggregate class, and public abstract void creating iterator. So concrete aggregate implements aggregate, and a method as a concrete iterator. Again, concrete extends main iterator class. So methods will be called as the first public void first, public void next, public void is done. So all this comes under the sample code. So this is the sample code. So two real-time applications. So the best real-time applications, one is tree traversal, another one is spell checking. So tree traversal, in-order traversal, pre-order traversal, post-order traversal. Any traversal algorithms need to define this iterator pattern. So next one is coming to the spell checking is also one of the main design problem which you need to solve by using this iterator pattern. So this is the two known uses. So next last template is related patterns. Three related patterns. One is composite, factory method, and memento. So composite iterators as composites defines a structure. So that's why composite totally related pattern for this iterator pattern. Next one, factory method. Here we are creating the iterator classes in wherever the need. Like for example, abstract list to the abstract class, to the abstract list class to the iterator class, list to the skip list class, concrete aggregate to the concrete iterator class. All the iterators can be created. So that's why here factory as a main class and product as a creator classes. So that's why factory method also pattern are helpful to the iterator pattern to solve the design problem. And memento nothing but memento intent is nothing but storing the object, restoring the object internal state. So here we are storing the state of an object without underlying its internal representation. That's why memento also supporting pattern for this iterator pattern. So this is related patterns, and this is about the iterator pattern. So thank you students. One point here. So I'm giving the assignment as an online quiz about this pattern, iterator pattern. If you listen end of this video, then you will attempt the questions. Either you can't attempt the online quiz questions. Okay, so see this video until the end. Okay, thank you.